In episode 29 of Mobycast, we conclude our series on how to set up your VPC to run ECS workloads. Welcome to Mobycast, a weekly conversation about containerization, Docker, and modern software deployment. Let's jump right in.
Hello, welcome, Chris, Rich, another Mobycast.
Hey.
Hey, guys.
So, Rich, what have you been doing this week?
We had a blog post that got picked up by one of the larger UI UX newsletters called Sidebar, and that's driven a ton of traffic. So I've been sort of going down that rabbit hole, seeing how far it's reached, and trying to figure out how I can make that happen more often, because it gave us like a 4,000% increase in traffic or something like that over the last 2 days. And I'd love to see that be sort of consistent, although I know it's probably not possible.
Well, that's exciting. Congratulations.
Yeah, thank you.
Chris, what have you been doing?
This has been back to school week. So it's particularly a milestone for us now that I have 2 children in high school and my wife is a school teacher. So Tuesday was a big day, and we're all adjusting to the new schedule and everything that goes along with it.
Same here, back to school week for me too. And our 3-year-old son is starting preschool this year. So yeah, big changes. All right. So I imagine that there may not be that many people that have hung on with us. We're on part 3 now of a fairly detailed technical conversation whose goal in the outset, we were ambitious in the first episode. We were ambitious thinking we were going to get to talking about how to create VPCs specifically for running your ECS workloads. And by the end of episode 1, we had covered some fundamentals about what VPCs were and availability zones and things like that. And then in the second episode, we still didn't even get to ECS. We were talking about more, just more foundational stuff about VPCs and private and public subnets and some security considerations. And so now I think we've gotten far enough to the point where people that, you one person maybe, that has listened to the first 2 episodes and understands kind of this foundational stuff that we've talked about on how VPCs work, you're going to be ready for this transition to talking about what we should do when we're creating workloads for ECS, how we should set up those VPCs. So, Chris, did I essentially summarize it right? Did you want to add anything more to the summary of where we've been and what we're going to do today?
No, I think you stated it well. I mean, we covered a lot of foundational groundwork that will really set the stage now to kind of with a good understanding of that, we'll set the stage for okay, and how do you actually run your ECS workloads in a VPC in a best practice way? And it's actually super simple. Like once you have those basics in place and set things up, there's not a lot to it. So hopefully the homework we've done on the last 2 episodes will pay off here, and this will be a pretty straightforward discussion of how to get ECS running inside your VPC.
Great. So, what is the super simple thing that we have to do?
Right. So maybe just to refresh a little bit, we talked about inside your VPC the concept of public subnets and private subnets. Mm-hmm. So that's an important point to remember here. Another consideration that we'll have when we set up ECS is what needs to talk to these services that we'll be running on ECS. So do they need to be accessed from the open internet, or are they something that's just within the VPC only? So some good examples of this would be, let's say you have some clients, and whether they be a web client or maybe a mobile app client, those are going to be outside your VPC, right? They're out running on the open internet. So those will obviously have to come into some front door that's publicly accessible. So whatever resources that are responsible for establishing those connections will need to be on a public subnet. Conversely, you may have some services, some microservices that provide foundational components to the rest of your architecture. And those may not be directly hit by outside components. They may only be consumed by your backend services themselves. So those may not need
Right. And that was a bit of a mouthful, these foundational microservices that serve up, stuff that you only need to see inside a private subnet. So can you give me an example of what one of those might be, what information it might serve up?
Sure. Maybe an example would be, let's say you have like a photo sharing app on your mobile phone. Mm-hmm. And so you'll have maybe a front end API service that's providing kind of like just the frontline communication with that mobile app. So things like, I'm uploading a photo, or I want to go get the high resolution version of this photo, or I want to see like all photos that have been tagged with cat or something like that, right? So that's going to be out on the open internet. Now, maybe you have multiple applications across all your projects that have this like just basic fundamental need of saying like, I need to store an image somewhere inside Amazon, inside the cloud, and I need to retrieve it, and I need to do things maybe like compression or there's metadata information I want to track. But it's kind of like a common thing, right? So like this whole idea of like storing an image, retrieving an image, it may not just be used by that application, by like other applications that you may have. So maybe the way that you architect it is you create another microservice that all it does is just deals with images, and it determines how they get stored efficiently and how they get retrieved efficiently. It does all the security considerations associated with that, and that just may be a microservice that you have. So that would be something that's probably within the VPC only. So it would be basically protected on the private networks because it's only going to be consumed by your other services. So in our case, it would be that API service that we have that the mobile clients are talking to. In order for it to handle the upload request that comes from the mobile app, it may very well defer some of that processing to this back-end helper microservice that knows everything about images.
Okay, that makes sense to me. Cool. So now we have sort of examples and hopefully just conceptually understand the difference between services that would live in a public subnet and ones that would live only in a private subnet.
Cool. So, and we've talked about this before with ECS, how ECS is composed. You define, when you're running host-based ECS, you define clusters. Clusters are sets of EC2 hosts that can run your workloads on them. And that's what we'll talk about here.
Hey, this is Rich. Please pardon this quick interruption. We recently passed an internal milestone of 10,000 listens, and I wanted to take a moment to thank you for the support. I was also hoping to encourage you to head on over to iTunes and leave us a review or a rating. Positive feedback and constructive criticism are both incredibly important to us. So give us an idea of how we're doing, and we'll promise to keep publishing new episodes every week. All right, let's dive back in.
Okay, are you going to do the thing that I was hoping you would do, which is you just said host-based ECS. And for some reason, I don't remember using that specific term before. And what hosts as opposed to what other types of ECS are there?
Right. So, a relatively recent development from AWS is it's Fargate, right? So this is basically where you don't have to manage the host anymore to run your ECS workloads. You think of it as serverless ECS, where basically AWS is managing your host for you.
Got it.
So we're specifically talking about host-based ECS here, where you're setting up your cluster and you're populating that cluster with EC2 machines, right? So as part of that, we need to decide, okay, for these EC2 host machines that make up our cluster, where do they reside? So you'll have, and how do they, what do they look like and how do they get created? So we'll have launch configurations associated with this, a launch configuration to dictate what those EC2s look like, and where they get placed. And then you'll also have an auto scale group definition for this as well, to control like how many of these nodes you have and when do you scale up, when do you scale down, and whatnot. So one of the best practices with ECS from a networking perspective is that regardless of whether or not the service is providing capabilities to things that are out on the open internet, there's really no reason to have those EC2 machines on public subnets. So a best practice would be to just make sure all of your machines inside your ECS clusters, go ahead, put them on private subnets. So they're not accessible from the outside world. They won't have public IPs. They're just blocked off from that. So they're internal to the VPC only. So that's one thing that you want to do. And so then how do you actually let these clients that are out on the open internet talk to these things? And that's all done through however you're directing traffic to them, whether it be a load balancer or maybe it's API gateway. In our case, we definitely, a lot of times we'll use load balancers, and that's kind of our preferred choice for kind of our architecture, how we set it up. So for those services that need to have clients out on the open internet, we'll create front-end ELBs for them and those ELBs will be on public subnets, but the ELB can surely talk to the private subnet. So the ELB is a proxy, and it's basically, that's the only thing that's on the open internet, and you can lock down what ports it communicates on and that accepts ingress traffic. And then you can also lock down the what goes out of it to your backend machines as well. So that's something to keep in mind, is that for your public facing services front end with an ELB that's on a public subnet. Conversely, for those services that are to be consumed privately, so your foundational microservices, if you will, like we talked about. So we talked about that, maybe having an image service, front those with a ELB that's private. It's on a private subnet. So the only things that can actually access that service through that ELB would be machines that are actually on within the VPC itself. So we have that lockdown secure.
Right, that makes sense. So I follow what you're saying in terms of getting API access, either inside the private subnet or publicly. But I guess one question that occurs to me is, sometimes the access you want to these machines is not just API access. Sometimes you want to actually log in and see what's happening on a machine that maybe has several containers running on it. So one of these EC2 instances may have several tasks, which are Docker containers running. If you're always putting your ECS cluster in a private subnet, how can you get in there and see stuff in there?
Yeah, so you have a couple choices there. One thing you can certainly do that's pretty straightforward, and probably like the easiest thing to do would just be create a jump box. Mm-hmm. So you would have a single.
Is that also known as a bastion server?
Yep. So you have the single machine that's out on that allows SSH access, and you lock it down to specific IP ranges for source. So maybe from your office. What your IP range is going to be, so you lock it down so that only origination IPs from that range can actually access that jump box. Right. And then once you're now on the jump box, you're now within the VPC. Right now, from there, you can then SSH into one of the machines that's on a private subnet. So that's one approach. Again, pretty easy to set up, but also it requires that maintenance, making sure that you have set it up correctly. It's pretty easy to also screw it up and to make it too wide open, and so you deal with that. So the preferred way of doing this is to set up a VPN tunnel between you and the Amazon, your Amazon VPC, and lots of different products and services out there for creating these VPN tunnels. There's some stuff out there that's free, like Soft Ether. There's other ones that are relatively low cost, like OpenVPN, and then there's tens of other products out there from other big networking vendors and on the Amazon AWS marketplace and whatnot. So lots of options out there for doing it, from free to something that's paid and supported. So again, pretty straightforward to get that set up. But I would definitely recommend that. Set up a VPN tunnel for your VPC, and then that way, when you want to access one of these machines that's on a private subnet, just establish your VPN connection, and now you're basically, once you have that connection in place, you're within the VPC itself, so you can just SSH directly from your machine into that using the private IP address.
Something that occurs to me thinking about this is that, there's a lot of pieces to this. There's setting up the VPC with its subnets and their security rules, and there's attaching NAT gateways or attaching internet gateways. There's potentially having a bastion server or creating a VPN. And then there's this whole idea that we're doing some best practices by running our ECS workloads inside a private subnet. But despite all of this, despite the fact that we're doing these best practices, it does feel complex enough to me that mistakes would be quite easy to make, even by very well-intentioned, very good, organized people. So I guess, I don't know, the kind of takeaway that's in my mind is that your applications, if they have stuff that is a target of hacking or has sensitive data and information in it, or personally identifiable information, not only do you need to do this best practices in terms of your setup of your AWS stuff and your ECS workloads, but really your applications need to be heavily responsible for managing their own security and securing their own stuff. So that's good authentication, authorization, all that stuff needs to be super, super good across all your services, applications, et cetera, within ECS. Because it just feels really, very complex. This whole orchestration of networks and components inside AWS is not enough. Is the takeaway I'm feeling.
Yeah, security is an onion with many layers for sure. Yeah. So don't rely on one layer. Have backups, right? So in case there's a breach at one layer, there's another layer that's protecting it.
Yeah. One of the easiest things in the world would be, I was away from the machine that had a VPN and I needed to go and do something on the ECS cluster. So I set up a quick bastion server and I forgot to, narrow it down to just the IP address that I was coming in there from, and I left it open to the world, but I was going to shut it down and I forgot, and oops, now all of a sudden you have a wide open VPC.
Mm-hmm. Yep. And this is absolutely the stuff that happens every single day, right? These are the things that, you read about it in the news, or that there's been a breach, there's been and it happens to, companies small and large. So it's one of those things where, most of the time, I think we all kind of know what the right thing is to do, but then that ends up being kind of like too cumbersome.
It's hardly ever the expedient thing.
But that's a really good litmus test, right? Of how secure things are, is the convenience factor, right, for you to do things. And if something's really easy and simple and convenient, then it's probably a smell that says it's not very secure.
Right. That's interesting.
Right. So if you've got to do a few steps, before you can make that connection, then that's probably a good sign.
Mm-hmm. Mm-hmm.
Right. I was just gonna just another thing to kind of round this out, which is kind of best practices with setting up ECS on your VPC, would just be, in addition to the being smart about private versus public subnets and putting your cluster EC2s on the private subnets only, always, would be to also use security groups to your advantage to further lock this down. So we talked about, you can set the ingress and the egress rules on your ELB to really make that fine level detail. So would recommend on your these ELBs that are fronting your ECS services, create a security group rule that only allows those ELBs to talk to your ECS cluster. I mean, there's no reason for it to be able to go to talk to anywhere else. Conversely, set up a security group for your ECS host machines such that their ingress only allows connections from your ELBs. There's no reason for it to accept, port 80 traffic or port 443 traffic from any other machines, right? Because that's the only way really that requests should be routed into it. So you can with a few simple rules, you can really kind of lock this down and make it so that the service area is much smaller.
Super good idea. Great. Well, I think that we finally turned the corner and talked about ECS and VPCs, so we can pat ourselves on the back. Is there anything else before we sign out for today and say goodbye?
No, just thanks for sticking with us again. I think that, covering the ground that we did in the last 2 episodes is that foundational stuff that we just need to understand, like what makes up a VPC and all of its components. But when you actually say, okay, now I want to run something on that, like ECS, pretty straightforward. And you can keep it really, really simple. And this is one of the benefits of containers, right? Is that you don't have to have one machine per service. You have this pool of resources that are your cluster machines, and you have N services that you want to run, and you let something like ECS schedule them and run them, and you just have to do a little bit of configuration maintenance on those cluster resources, and just make sure that you set up a couple security groups, you set up a couple subnets, private and public subnets, and you'll have a very, very good security posture and a very efficient way for running your code.
Great. Thanks again, Chris. And thank you, Rich, as always, for putting this together for us.
Yeah, thank you.
Talk to you next week.
See you guys.
Bye. Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/29. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.